Its sides climb at an angle of slightly less than 52 degrees, rising to a summit of 480 feet. But how did they manage to maneuver 2.5-ton blocks to such an incredible height without the crane or the block and tackle? It was a challenge to the ancient Egyptians and still remains a mystery to modern archaeologists. Egyptologist Mark Lehner has spent 30 years studying the pyramids hands-on.
My approach to the question was, where are the quarries? What kind of a ramp can you get from the quarry to the pyramid in a functional slope?
Lehner and almost all Egyptologists believe that some kind of ramp was used to raise the stone blocks. The type of ramp remains a mystery. Did they approach the pyramid straight on? Zigzag up one side? Or spiral around it?
It's not a problem that's been totally solved, and I've given my suggestions. I've tried to base them in the landscape, but a lot of it is still inference.
Because the ramps were dismantled once the pyramid was complete, only fragments of evidence are available to archaeologists. But it was ramps and sheer muscle power that allowed millions of blocks to reach the summit. Once in position, the builders faced a new task. The blocks had to be fitted together. Surprisingly, in such a precise build, a large proportion of the internal stones were just roughly finished. The gaps between them were filled with rubble and gypsum mortar.
In between the blocks were stuffed lots of limestone chippings mixed with a huge dollops of mortar. And it sets just like modern concrete.
But every stone that would be visible when the build was completed was placed with amazing precision. In the Great Pyramid, the blocks of the burial chamber fit precisely. The sides of these blocks had to be almost perfectly flat to make these astonishing joins. This precision engineering was achieved using the most rudimentary of tools.
Yes, we'll use this rods and string tool in order to find out whether the surface is truly flat. And by using a third rod, which is the same length as the other two rods joined by the string, which is now pulled very taut, we can see if it just slips under. Now, we've got a bit of a high spot there. Now, in ancient times, they would mark that simply by putting some red ochre on, just to remind the workers where to go to, and check along the length of the string.
The ancient mason would use the rods and string to spot imperfections and then mark them with red ochre to show where more work was needed.
Using two further tools, this one being a flint scraper and this one being a sandstone rubber, now we can use the marks as a guide to scrape away the high point like so. And it's obvious that as you scrape, the mark disappears, and with it, of course, the high spot.
This same technique was also used in the final stage of construction. The rough internal blocks were covered with an outer casing of perfectly smooth stone. This was carved from the highest grade limestone and had to be carried across the Nile to the pyramid site. With this polished casing, the pyramid would have shone dazzling white in the Egyptian sun.
But when the pyramids were newly encased in this special limestone, they must have been blinding in the sun like newly fallen snow.
To achieve this, every casing stone was cut to sit perfectly with its neighbors. When complete, the Great Pyramid of Giza was covered with thousands of these facing stones. Sadly, they have long vanished, taken to build the mosques and castles of Cairo. But facing stones can still be seen on the cap of Khafre's pyramid. Even with all the Egyptian skills and tools, building the pyramids was still an